Welcome to my classroom. A challenging problem of using a Borken calculator is discussed in this video. You expect to have a good understanding of trigo functions and their inverses for solving this problem. Here is the problem. A calculator is broken so that the only keys that still work are the sine, cosine, tangent, arcsine, arccosine, arctangent buttons. The display initially shows 0. Assume that the calculator does real number calculations with infinite precision. All functions are in terms of radians, so that by pressing some finite sequence of buttons, the calculator will yield 2/3. Take a moment to think about the question first. In case you are not clear with the definitions of the terms used in the question, the following points are for your reference. 1. Radian. Other than degree, radian is a commonly used unit for angles, particularly in advanced mathematics. For degree, an angle of a complete turn is equally divided into 360 parts. An angle of 1 degree means an angle of 1 part of the above division. Thus, a right angle refers to a quarter of a complete turn, and it takes 1/4 of 360 parts, that is 90 degrees. For radian, the arc length of the unit circle is used for measurement. The angle spanned by 1 unit in arc length is said to be 1 radian. Thus, a right angle is pi/2 radian, as it is a quarter of the circumference of a unit circle. 2. Inverses of trigo functions. Arcsine, arccosine, arctangent are the inverse functions of sine, cosine, tangent, respectively. Take arcsine as the example for illustration. The function sine transforms an angle into a value. Say, sine turned pi/2 to 1. That is, sine pi/2 equals 1. The inverse function arcsine reverses the process. That is, take 1 back to pi/2. In other words, arcsine 1 equals to pi/2. The domain of the function sine is all real numbers and the range is from -1 to 1. To make the inverse function well defined, the domain of arcsine is from -1 to 1, and the range is from -pi/2 to pi/2. Similarly, the domain of arccosine is from -1 to 1, and the range is from 0 to pi. The domain of arctangent is from -infinity to +infinity, and the range is from -pi/2 to pi/2 exclusively. To ensure the functions can be converted among sine, cosine, tangent, and their inverses, the common part of the range of the inverses is considered. That is, the range of angle concerned is between 0 and pi/2. Let theta be an acute angle in radian measure. Consider the right angle triangle as shown. Then, thus, see if you have more idea of the solution with this information. Try. Since the starting point is 0, we would like to construct a way of turning 0 to a larger number. By looking at the right angle triangle for the trigo functions and their inverses, we try to set up a function transforming root x to root x plus 1. Thus, we consider the functions tangent and cosine. Combine the functions. Define f of root x. Now, we need to take the reciprocal, putting the denominator downside up. Thus, we consider tangent and the complementary angle. For reciprocal, for putting the complementary angle pi/2 minus theta back to theta, combine the result. That is, thus, define gx. Now combine functions fx and gx, define hx. These 3 functions tell us the key in sequences, and Now, our target is to yield 2 over 3, which is root 4 over 9. As the function h changing root x to root x plus 1, it is expected to consider the reciprocal of root 4 over 9 by function g. So we consider root 9 over 4, which can be regarded as, this number can be obtained by using h 2 times from root 1 over 4. From 0, applies functions h and f, root 1 over 4 can be reached. Let me show the steps expressively. Starting from 0, apply h and have 1. Apply h again and have root 2. Apply h the third time and have root 3. Apply f and get root of 1 over 4. Apply h. Apply h one more time, that is 3 over 2. Take the reciprocal by g and yield 2 over 3 as required. This problem is modified from problem 2 of the 24th USA Mathematical Olympiad in 1995. The original problem can be found in the Mathematical Excalibur Volume 1, Number 5, 1995. Mathematical Excalibur is a math magazine published by the International Mathematical Olympiad Hong Kong Committee. Each issue of the magazine contains 4 pages with articles on mathematics, Olympiad Corner, where Olympiad problems from other countries are given, and Problem Corner, for readers to try and submit their solutions. If you are interested in mathematics and you want to get a taste of Math Olympiad and take up the challenge of solving problems provided there, here is the link for you to explore more.